All right. Today's presentation, everything about SBR. What exactly is SBR? SBR is an abbreviation for sequencing biological reactor, sequencing batch reactor, whatever you might call it. All right. Okay, it's not going away. Okay, this is only what we can see in the present circumstances. Okay, let us have a brief recap of what we have been talking previously in the last few sessions. We talked about what is sewage, how to treat sewage, why to treat sewage, and what are the impacts of not treating sewage. What are the various steps and processes involved in sewage treatment? What is the equipment required for sewage treatment? And in the last two sessions, we discussed extensively about MBBR. And we went too deep into what exactly is MBBR. We compared with the SBR. We understood what are the advantages, disadvantages of SBR, where it is ideal, and where it is not so suitable, right? What are the operating costs? And finally, we also discussed about what are the problems that come in a regular conventional MBBR and how to solve them. The same thing we are going to do. The only difference is this session we are going to wrap up in less than 1 hour's time. And we'll have 10 to 15 minutes time for the question and answer session. I have some suggestions from some of our guests that we should restrict this strictly to 1 hour, right? So considering their request, we are restricting this to 1 hour. So 12 max to max 12:05 will be closing. Any more questions you have, I'll be happy to answer them in private, not as a part of this webinar. All right. Okay. Now moving forward, I just explained what we are going to discuss today. Today we are going to discuss a little bit about what is batch reactor, or batch process and continuous process, what is attached growth, what is suspended growth. We are going to see SBR flow chart and some process tanks, details of process tanks, and advantages of SBRs. Also, where we can use SBR, what are the equipments that are regularly used in any SBR treatment plant, what are the problems, and finally, SBR versus MBR, what are the similarities and differences. A very brief recap. Sewage is the wastewater that is coming from human usage anywhere. This human usage can be there in a commercial establishment, in a residential establishment. But when it is done in a commercial establishment like a restaurant, it is slightly different. The parameters are different. So when you say sewage, it strictly means wastewater that is coming from our homes. If you look at the wastewater that is coming from a restaurant, its characters are different. That is rich in oil and food. Whereas the wastewater that is coming from our home is more of a mix of kitchen wastewater, laundry wastewater, and toilet wastewater. And one misconception that a lot of people have is sewage means toilet water. That's not the reality. On an average, an Indian uses about 150 liters of water every day, out of which 90%, that is 135 liters, will come out as sewage. From this, max to max 20 to 25 liters comes from toilet flushing. We don't flush the toilet more than 2 times or 3 times a day. And that also today, most of the toilet flushes have half flush also. If you go for susu, you would not be flushing it fully. You would be flushing it half, right? Considering this, the wastewater primarily comes from our washroom application, like our bathing. That is a major contributor. Then the second major contributor is laundry. The third major contributor is kitchen, right? So what are the things that are there in sewage? If you look at sewage, by definition, it is 99.95% water. H2O is 99.95%. Whatever impurity that has got added by way of washing clothes, by way of our bathing, by way of our washing utensils, right, by way of our toilet flushing, are 0.05%. 0.05% impurity. And what does this impurity comprise of? These impurities are primarily physical impurities, right? That is food particles, or oil that comes from your cooking or oil that comes from washing your utensils, right? And when we bathe also from our body, the oil layer, the grease layer is removed, right? And from the clothes also, what you are removing when you are washing a cloth is dirt and grease. All these are removed when you use a detergent. So sewage primarily consists of lot of detergent which contributes to what is called COD, chemical oxygen demand. The food particles, the organic content. We all studied in our plus two or maybe around that time that carbon is a building block for everything. Carbon and hydrogen, hydrocarbons as they are called, they are organic in nature. That means there is some energy. If we take our petrol, there is uh, hydrocarbon in that, right? That part, primarily the food part, contributes to BOD. Now, suspended solids. What are these suspended solids? Suspended solids primarily come from the food that we are eating, and also sometimes the hair that we that comes out when you wash your hair in the washroom, and your fecal matter, right? And vegetable peelings. These are the things that come out as suspended solids. And ammonia and nitrogen are some of the nutrients that come from our stomach itself. All right. Okay. Now, why should we treat sewage? If you look at World Health Organization statistics, the number one killer in the world is waterborne diseases. That is why whenever a rainy season starts, the beginning of the season, we have plenty of diseases coming up and a lot of deaths happening. And majority of the deaths are in lower age group. That means children are the primary target for these waterborne diseases. Waterborne diseases are like our malaria, typhoid, right? These are the waterborne diseases, some of the waterborne diseases. Apart from this, the dissolved ammonia, phosphate, nitrogen, these things are contributing in a large way to some of the diseases which are not directly linked. Like people are getting more cancer nowadays. That is primarily contributed to, the main reason is excess quantity of ammonia, nitrogen. These are the things. And this excess quantity of ammonia and nitrogen are going and disturbing our plants also. If you use water which is rich in ammonia and nitrogen, the plants intake that and part of their food carries it. Okay. Now, this is the major reason. Please understand this. Like air pollution, sewage pollution impacts everybody. There is no escape. If you look at any city, every lake in any major city is not dry in summer. So you go to any rural area, all the lakes dry up in summer. The reason being, we are pumping or we are allowing untreated sewage to go into the lake. And this untreated sewage is going into underground. From the underground through our borewell, it is coming out with some partial treatment. Partial treatment means some physical impurities may have been removed and some small biological process may have happened, but that still is untreated sewage. All right. So by drinking this untreated sewage, we are spoiling our health, and the bad part is we are not even aware of this. And finally, one of the main reasons why people treat sewage is because government insists that we should treat sewage because it is impacting everybody's health, right? So because of these government rules, all the builders, all the major buildings are supposed to have sewage treatment plants, and that is what is giving us business here. And finally, the upcoming reason why we must treat sewage is sewage is the most reliable source of water, and there is only 0.05% impurity. If you just take out that 0.05% impurity, it is again 100% water, which can be good for reuse. And water shortages are staring at us. Water shortages are there everywhere. In every city, there is water shortage. We can overcome this water shortage by treating our and reusing our sewage. So as long as we use water, there is sewage. When there is sewage, you can treat and reuse it. This can be a closed cycle. All right. Now moving forward, let us understand a little bit about, this is the recap. What we are doing is a recap of our previous discussions. How sewage treatment happens. Sewage treatment is a natural process, right? Natural process means something in the nature will come out and eat what we want to take out. Why do they come and eat? If you leave a lump of sugar or some jaggery in your kitchen platform, in 5 minutes time, flies and ants will come and start having it. How do they know that there is food there? It is an instinct, right? It is their sensory perception. So this is visible to our eye. Invisible to eye, to our naked eye, there are plenty of bacteria which grow on these types of food. They come and consume this. Likewise, there is bacteria which is invisible. Bacteria is a unicellular organism. Unless you put it under electronic microscope and watch, you can't even see bacteria. In water, there is plenty of bacteria, but 99.99% of these bacteria are harmless to us. World is full of bacteria, but 99.999% are harmless. They don't impact us in any manner. What can a unicellular organism do to a body of our size? Now, there could be very few bacteria and viruses which are adversely impacting our health. Our objective is to avoid them. And our objective is to enable this bacteria to come and eat what we want to take out. We don't have to do anything special to grow this bacteria. If you just have food in water, that means whatever we are trying to take out, the food particles, the oil particles, the fat particles, the detergent particles, these are all organic in nature. So some living species will come and eat that. It could be fish, it could be bacteria, anything. And this happens in the presence of oxygen. This is called aerobic bacteria. There are two types of bacteria. One major type of bacteria is called aerobic bacteria. This bacteria requires an external source of oxygen, which is atmospheric air, and that our bacteria grows and consumes what we want to take out. And once the bacteria eats whatever it wants to eat, whatever is available to eat, the water is free from this contaminant. And the bacteria, when there is no food, it dies in a matter of minutes. Likewise, there is a second type of bacteria, which is called anaerobic bacteria, which does not require an external source of oxygen. If there is no external source of oxygen, how can this survive? You might ask. This basically dissolves the water and takes out oxygen from there. There are two types of main biological processes. One is aerobic, second is anaerobic. In most of the sewage treatment plants that we talk about today, we use these two or a combination of these two. So a combination of these two is also called an anaerobic process, anoxic process. Anoxic means there was air, but not excess quantity of oxygen. There is a small quantity of oxygen available, but not excess quantity of oxygen available. That is a process called anoxic. That means you have aerated water, you stopped aeration, and you have sent it into anaerobic condition. That kind of a process is called anoxic. All right. Why two processes? What is the significance? External pumping of air is required if you are using aerobic bacteria. That means you need to spend energy, you need to have equipment which is pumping atmospheric air into this. This is achieved by what is called linear air pumps or air blowers or centrifugal air blowers. So some kind of mechanism where atmospheric air is taken and given into water. Anaerobic means you are not doing anything. You are just putting it into a sealed airtight container. This is what happens in our septic tanks in villages. All right. So septic tank is also a biological process where 60 to 70% of BOD COD is reduced. Now moving forward, that means if we can just summarize aerobic and anaerobic process, aerobic process requires external intervention by providing air. Anaerobic process does not require any external intervention. It does not require air. Okay, but why not use anaerobic bacteria completely? Because there are systems constraints. Anaerobic bacteria can digest up to 60 to 70%, and remaining 30 to 40% is still there in water, which makes it unfit for human use. And also, anaerobic bacteria generates methane. And also, anaerobic bacteria converts the water into brownish black color. So the water will be looking like dirty, right? And once that color comes, it's not possible to remove that. So for these reasons, anaerobic bacteria alone or septic tank alone is not a suitable process. A septic tank with a combination of biological aerobic process is what the fashion today is the technologies that we are talking about. All right. Moving forward, sewage treatment can be divided into three major parts. Three major parts: primary treatment, where you are actually not removing it, but making the water more suitable for treatment by removing sand, by removing physical impurities, which can potentially spoil your equipment, downstream equipment like pumps. If there is sand, the pump impellers get worn away very fast, right? If there is cloth, the pump housing will get choked, right? So we need to remove these things. So the primary treatment or also preliminary treatment is something where you are conditioning the water for removing for further process. Sometimes primary treatment also involves removal of floating particles like oil and heavier particles like suspended particles or heavier particles like food. These two are done by settling tanks, a primary settling tank. All right. Now the main process, the biological process is what is called secondary process. Secondary process is where we are actually removing the organic content from wastewater by growing bacteria. This can be using aerobic means or anaerobic means, attached growth, suspended growth, all these things. Now, the third part of the treatment is destroying whatever bacteria has been grown in the previous treatment and filtration for further reuse. If it is for uh, agriculture, water can be let out after secondary treatment. It does not require any tertiary treatment. All right. These are the three basic parts of treatment. It is not relevant or not relevant for us to understand which is more important. All are equally important. All right. Now, one important concept we need to understand suspended growth versus attached growth. Suspended means we are talking about bacteria growing and eating what we want to take out. So, where does this bacteria live? This bacteria is going to be in water. Bacteria is something that we can't see with the naked eye. We need a microscope to see bacteria. So what happens is, in the absence of any uh, substance to which this bacteria can latch on, bacteria is suspended in water. Along with water, it goes away. So what is the disadvantage? In a sewage treatment plant, water is coming in continuously, water is going out continuously. So when the water is going out, along with the water, bacteria is also going out. So any system that is working on suspended growth is a little bit more inefficient. It is not as efficient as attached growth. So some scientists, what they have done is they provided some plastic sheet. They just put a plastic sheet to which bacteria will latch on and grow. Like if you see fungus grows, it'll get attached, right, to your the walls of your water tank. In the same manner, by providing some kind of means, we enable the bacteria to attach and grow. So this system of attached growth is lot more efficient compared to suspended growth. All right. Now, this is how MBBR media would look like. MBBR media means one of the more recent developments, not exactly recent, maybe 20, 25 years old development, where you are using this shaped plastic media. Why this gear-shaped plastic media? For 1 square cubic meter of this media, you get something like 400 to 500 square meters of surface area. And this plastic media is suspended in water. So it does not go to the bottom of the tank. It is suspended in water, in sewage. So in the aeration tank, when you put this, you are reducing the aeration tank size. So compared to a 100 KL STP of 10 years or 15 years old, today you can make it into a 300 KLD STP just by adding this kind of media. So one of the major roles is like there you are converting your suspended growth into attached growth. And by doing that, you're increasing the capacity of your STP. But there are other problems. Other tanks may not support it, other process tanks. All right. Okay. Now, the attached growth is a process that is used today. Majority of the sewage treatment plants use attached growth, whether it is anaerobic treatment process or aerobic treatment process. Both use attached growth. All right. Okay. Now, what are the advantages of using this media? One is it requires less surface area because more bacteria is there in a compact small tank. Second is the process is more robust because along with your water bacteria is not going out. Bacteria is stable, so it can handle shock loads. Even if you give more uh, load in terms of organic matter, the treated water quality does not suffer much. Okay. This part we discussed in the previous session, batch versus, okay. Now, another concept that we need to understand is batch process versus continuous process. Continuous process means you are treating sewage 24 hours a day, 7 days a week, 365 days a year. You're not stopping the process for any reason. Batch process means you're taking the sewage into a batch, into a tank, into a reactor, into a vessel, whatever name you call, into one container, treating it and discharging it, then taking another batch. Right. The question is, which is more efficient? That's actually not the question. Both have its own purposes. A continuous process may be more suitable for a stable load, something like a apartment complex where we know how much of wastewater is going to come. A batch process is more suitable for a place where we don't know how much wastewater is going to be generated. If you take a hotel, we don't know how many rooms are going to be occupied. Right? If you take a function hall, we don't know when the next function is going to take place. If you go to a hospital, we don't know how many rooms are going to be occupied. If you go to a college, Saturday and Sunday are holidays. If you go to an IT building, weekly off will be there. There will be holidays, public holidays, where there is no load. Right. So due to these conditions, each has its own merits and demerits. So both are essential for us. We can't say I'll stick only to uh, continuous process or I'll stick only to batch process. Right. Now, continuous process by definition means it is very simple. It's easy to control. You're not doing anything much every day on a day-to-day basis. Whereas in a batch process, you need to understand when you have sufficient quantity for your next batch, transfer it, treat it, discharge it, and again wait for the next batch. That means there is certain level of automation required in terms of sensors, which will switch on the equipment, switch off the equipment based on the availability of wastewater. Now, this is a bit challenging. For a continuous process, we can think of MBBR, moving bed bioreactor, or extended aeration, or MBR, membrane bioreactor. These are all continuous processes. Okay, please understand, when I'm talking about a continuous process, it does not mean at full capacity. For example, if we have a 100 KLD STP, in the project beginning stages, we start with zero. After 1 month, maybe you have 25%. That means you are generating 25,000 liters. But your continuous process, the operator should adjust this 25,000 liters into 24 hours. When your incoming flow is increased to 50 KL, you need to adjust it to run 24 hours. So whatever is the volume, you are adjusting it into 24 hours. Whereas in a batch process, if you define a batch volume as, let us say, 100 KL SBR divided into 3 batches, so each batch is of 33 KL or 34 KL. You wait till you generate 34 KL. Then you transfer. Then you discharge, treat and discharge, and then wait for the next batch. All right. This is a fundamental difference. Okay. What are the advantages and disadvantages? Here today, our focus is to talk about MBBR. We discussed in 2 sessions at length. SBR, we are going to talk in depth today. It is a batch process by definition. So let us see what are the process tanks that we have in SBR. Before going that far, let me just see. Yeah. Okay. Like everywhere, there is screening. What is the purpose of screening? Screening is for removal of physical impurities, especially large capacity physical impurities. Anything larger than 10 mm, you put a screen, you put something like a mesh, and physically prevent it from entering into your next stage process. The next stage process in a small capacity STP is after screening. Screening is done using a bar screen or mechanical screen or a rotary drum screen, any type of screen. As long as it is taking out the physical impurities of 10 mm or above, it screening process is good enough. Then oil and grease tank. Oil and grease tank. What is an oil and grease tank? One of the main sources of uh, problem in sewage treatment is oils. Oils are not easy for bacteria to digest, even for human beings. For us, people who weigh 60, 70, 80, 90, 100 kgs, if we have a oil-rich food on a day, we cannot digest. So oil is difficult to break down. It's a tough molecule. Okay. So bacteria cannot digest oil easily. So oil-rich food needs a lot more retention time, much higher time. That's why in kitchen-based, restaurant-based wastewater treatment plants, the retention time is much higher. Often it can go up to 3 days. That means you hold the water effluent in a reactor for almost 3 days. Okay, to help the bacteria eat whatever we are trying to take out, primarily the oil. So oil and grease tank is nothing but a tank where you are reducing the velocity of water, incoming water. When you reduce the velocity, heavier particles settle to the bottom of the tank, lighter particles raise to the top of the tank. When the oil is rising to the top, from the bottom side, you are allowing clear water, oil-free water to go to the next stage. Your next stage is a equalization tank, collection tank, or collection cum equalization tank. Different names. The tank is same, the purpose is same. Why do we need a collection tank? To recap again, we don't have uniform flows in the day. In the morning, when people get up and get ready for their work, they shower, they use wash basins, they use toilets. A lot of cooking takes place in the morning. So 40% of the sewage is generated in the first 3 hours of the day, whether it is 6 o'clock to 9 o'clock or 7 o'clock to 10 o'clock, depending on the season. If it is summer, probably 6 to 9. If it is winter, it is probably 7 to 10. So 40% of wastewater is generated in these 3 hours of time. These are called peak hours and peak flows. Okay, so we need to have a storage tank which can handle this water, right? Which can hold as a reservoir for this water. We are holding it and distributing it for the next 24 hours. All right. Now, in a SBR, if you see, what should be the volume of our equalization tank? Equalization tank volume should be always equivalent to your peak flow. Peak flow multiplied by peak hours. A peak flow is defined as 3 times the average flow. On an average, let us say we talk about a 100 KL STP. Average flow is 100 divided by 24, something like 4,126 liters per hour. And that is the average flow. Your peak flow will be 3 times multiplied by 3. 3 4 the 12, something like 12,300 or so. Okay. And what should be your collection tank volume? Three peak hours. That is 3 into 12,300. All right. That is 36 or 37 KL. So this should be your equalization tank volume. Normally, we round it up to 40% of the STP capacity. So as a thumb rule, your collection tank volume should be 40% of your STP capacity, whether it is MBBR or SBR. More is better if cost is not a factor. But for going for bigger tanks, you need to spend more money. All right. But the minimum required is 40% of your STP capacity. Then from here, we are pumping the water into SBR. When we are talking about an SBR, a sequencing biological reactor, what are the sequences in that? We are talking about a batch reactor. That means I need to fill the reactor. I need to aerate it or biologically treat it. Then I need to settle it. Then I need to remove the water that I have added. So how this works, if you see, it is a reactor where there is lot of sludge. Sludge means live bacteria. There is a lot of live bacteria. Almost 66% of the tank has live bacteria. 33% of the volume is the fresh sewage that you are adding, right? Total 100% of the capacity. Then you are aerating it. After aeration, you are switching off your blower. You are allowing it to settle. And after it settles down, that means all the sludges settle to the lower levels of the tank. You are withdrawing what you have added to the process. Let me repeat again. SBR process tank. The main reaction happens in one tank. It is called a batch reactor. So from equalization tank, I am pumping water into the batch reactor. This pumping time can be 1 hour. In slightly larger capacities, it can be up to 1.5 hours. So 1 to 1.5 hour time, I am filling the SBR. All right. And when I'm filling, where is the bacteria? That means I need to have sufficient bacteria already there in the SBR. This is achieved by having a oversized batch reactor. In a MBBR tank, your retention time or your batch reactor size is something like 30% of your STP capacity. In a SBR process, your batch reactor size is 100% of your STP capacity. That means if I am treating sewage of 100 kl per day, my batch reactor in SBR is of 100 kl volume. But the fresh sewage that I'm going to add is going to come in three batches, 100 divided by 3. That means each batch is of 33 kl. So I'm going to add 33 kl of fresh sewage to 67 kl of sludge, which is already there in the SBR reactor. Once I add this, then I'll start my blower. This blower is going to be on for 4 hours or 5 hours, as the case may be. During this time, 4 hours or 5 hours, the bacteria present in the 66% of sludge or 67% of sludge is going to consume whatever I want to take out from water. Then my blower is switched off. Then I allow the sludge to settle to the bottom of the tank. Sometimes we add something like alum or polyelectrolyte to enhance the settling character of the water. Then the clear water from the top layer, from the top 1/3 layer, is taken out using what is called a decanter, a floating decanter. This floating decanter is nothing but it's floating on top of the water, allowing only clear water to go out. This operation is achieved by using a floating decanter connected to a electrically operated solenoid valve. The solenoid valve will open on a signal input from PLC 1 hour after the blower is switched off. Then the water is going out. The clear water from the top layers is going out. And at the end of the process time, that means after the top layer has come to the 66% level, the solenoid valve will shut down. How does the solenoid valve know that the level has reached? There will be a level sensor. That means the SBR process tank would require two level sensors. One high level sensor, which will tell the feed pump from the collection tank that the level required in the SBR is achieved. It will switch off the feed pump. Then it will switch on the blower, and then blower will run for 4 hours or 5 hours. Blower is switched off. Then after lapse counting down of 1 hour 60 minutes or 1 hour or 60 minutes, then the solenoid valve is opening. The floating decanter is withdrawing clear water from the top of the SBR tank. And when the SBR tank level reaches a predefined low level, that means 66% of the depth, the signal will go to the solenoid valve. The solenoid valve will shut down. Right. That means this total process is automated. I require two level sensors, two timers, right, to keep this functional. Now from SBR, from the outlet of SBR, the process is same whether we use MBBR or SBR with some small difference. For example, in MBBR, my chlorine contact tank volume would be equivalent to a couple of hours of retention time. That means if I am treating 4 kl or 4.1 kl per hour in MBBR, my chlorine contact tank volume can be maximum 12 kl, 3 hours retention. Whereas in SBR, my batch volume is 33 kl. I have to take out this batch in less than 1 hour. So that means my chlorine contact tank volume should be 1/3 of the STP capacity or minimum equal to the batch reactor. All right. So that makes it civil works from point of view. The chlorine contact tank is of bigger size. The SBR batch reactor size is also bigger, much bigger. What are the advantages? You are spending more money constructing these two bigger tanks, large capacity tanks. One reactor doing two jobs. This is on the physical side of it. On the treatment side of it, there are multiple reactions taking place in the SBR. Unknown to us, there is sewage, there is sludge. 66% of sludge is there in that. There is an anaerobic decomposition taking place. When the process batch is not on, when the blower is off, there is an anaerobic digestion happening in the SBR. Okay, then when you are giving fresh sewage, a different type of anoxic reaction takes place. And when you are aerating, aerobic bacteria grows and aerobic reaction takes place. And by controlling the blower on and off sequentially within these 4 hours or 5 hours, I can change the parameters of treatment. Sometimes I can give more oxygen, sometimes I'll make it anoxic. So by changing these parameters of blower on and off within these 4 hours, 5 hours, I can get my desired quality of water. But this is at a much, much advanced level. In India, we are not doing it. But this is the core and basis of SBR. Unfortunately, we are not doing it because we are not going deep into ammonical nitrogen, phosphate reduction, those things. When those things become essential, all SBRs would be required to switch on, switch off within these 4 hours, 5 hours also. The blower operation would be controlled by a PLC with a variable frequency drive. All right. Now, after the chlorine contact tank, where you are adding hypochlorite, it will go into pressure sand filter, activated carbon filter, and get reused or discharged, whatever is the case. From the SBR, we withdraw excess quantity of sludge once in a while. Maybe first 1 to 2 months, there will be no excess sludge. But once we have sufficient quantity of MLSS, we remove the excess quantity of sludge. All right. Now, SBR in a smaller STPs up to 500 KL, this is the process followed. But this is not ideal up to 500 KL. Where exactly world uses SBR is above 500 KL. This is what is of interest for us. Whenever we have a large capacity STP, there is no collection tank. There are two batch reactors, SBR reactors. You are seeing two slice gates. The incoming sewage is going into reactor 1 or reactor 2 based on a gate being open or a pipeline with a solenoid valve being open. After the oil and grease tank, or maybe there is no oil and grease tank also, there is a screen. After the screen, there are the water is divided into two channels. Each channel is closed by a simple gate, a mechanical gate with electrical operation. So when the gate opens, like a dam gate, when the gate opens, sewage goes into that. When the gate closes, sewage goes into the other one. At any point of time, one reactor is receiving fresh sewage, one reactor is under process, right? So here we have done away with our collection tank. And after the process, common chlorine contact tank. What is the advantage here? In large capacity municipalities, there is no need to build a large capacity collection tank. We can just build two batch reactors. And after the batch reactor, you can have gas chlorinator, chlorine gas being directly pumped into that, which is actually not advisable in small capacity STPs because handling chlorine gas is hazardous. It's not safe for humans. All right. The remaining process is same. So for all municipal applications, if you see India and abroad, world over, SBR is choice number one, right? Like we discussed earlier, what are the process tanks? For SBR, you require collection tank, but if it is a large capacity STP, you don't need a collection tank. You need two batch reactors. SBR reactor means basically bioreactor where aeration is taking place. And there is a chlorine contact tank, right? Settling tank is not there in SBR, whether it is small or big, both aeration process and settling happen in one tank. All right. Now, the major difference is you have a PLC in SBR because the process is completely automatic. And apart from PLC, you have what is called a floating decanter. And then there will be level sensors. This floating decanter is to withdraw clear water. All right. In large capacity STPs, you will also have sluice gates, which are allowing water into one reactor or the other. Then pneumatic actuators, which allow air to go into reactor 1 or reactor 2. All right. So apart from level sensors, there are sluice gates and pneumatic actuators. And why sensors are required for these level sensors and actuators? We should know whether the gate is closed or not. If the gate is not closed, it's a fault condition. So you have to get a positive feedback saying that the gate is closed. So your large capacity SBR STP would require huge level of automation, huge number of sensors. All right. Okay. Now, what are the problems that come in most STPs? I have seen in Bangalore, the first preferred choice for even a 50 KL, 100 KL STP is SBR. Actually, SBR is not suitable for such small capacities, but consultants are asking for that, customers are asking for that, and we are providing. Okay, technically it is not right. MBBR is a preferred choice for small capacity STPs up to 500. We can suggest with our eyes closed. All right. Now, what are the problems? If we use SBR, one is it costs more, your civil works are more, and equipment is of larger capacity, and automation is more. And if a person who is operating the plant does not know anything about automation, most of the time the STP does not work. And why do you get poor quality water? In small capacity STPs, the floating decanter does not work properly. So people just remove the decanter and water comes like a channel. When it comes out, it carries a lot of suspended solids or the sludge, and the sludge goes into sand filter and carbon filter, choking them very frequently. This is problem number one in every major STP, SBR STP that I have come across. And how should we improve this? First thing is the maintenance should be proper, and we need to maintain the required quantity of MLSS. MLSS is critical here because there is no MBBR media in the tank. So the bacteria is suspended in water. How do we measure that there is sufficient bacteria? Using the MLSS jar. And use ultrafiltration to make it something like MBR. All right. Okay. We're done with our presentation. We are ready for your questions now. So all questions, please, we'll try and answer these questions as quickly as possible. Kishore, am I audible and visible? Are you ready for questions?
Yes, sir. Yes, sir. You are audible and visible.
Okay, great. Gautam, welcome. Your questions, please.
Hello.
Yeah, please go ahead.
I have a question here. This in SBR, the sludge
Yeah, please.
has to be taken out.
Yes.
This
You know,
how
every
we can
process,
take out this sludge.
sludge is taken out using sludge transfer pumps. There are pumps installed in your SPR.
Okay.
Most of the time, they are submersible pumps which are designed for handling sludge. And you have to take out the sludge only when you know that there is excess sludge. You have to measure
Right.
the quantum of sludge or MLSS using a MLSS jar. And when it crosses the defined limit, then only you withdraw a small quantity of sludge into your sludge holding tank.
Okay. In case of SBR, this blower we are making on and off.
Yes, exactly.
In a sequential manner.
Yes.
So for the specified period.
Period.
After
4
that,
hours or 5.
4 hours or 5 hours. After the blower cut off, how much time it is required to hold it?
Within 1 hour, 60 minutes. See, please understand, we have 24 hours in a day. In 24 hours, you want to take out 3 batches. So each batch is of 8 hours duration. In these 8 hours, please go ahead.
My question is, after the blower is cut off, after 1 hour, we have to transfer this liquid to the clarify tank.
Exactly.
So this how we will take out this water by dosing valve, or you say it is a 60% of MLS will be always it is retained inside the tank. Only 30% we are transferring from equalization tank to SBR.
Exactly.
So at the 60% level, I can keep a valve and I can transfer it, or I can draw with a pipeline the clear water.
Yeah, your question is very pertinent here. Let us say you have 4 meters water column in your aeration tank, SBR process tank, right?
Example.
4 meters is your 100%. 33% is 33 into 4. That is something like 1320 mm from the top, from the water level, or from the bottom 2700 mm. So from the bottom 2700 mm level, you put your electrically operated solenoid valve. You open this valve 1 hour after the blower is off.
The valve location is at this level only.
At that level only, yes.
After 60% of water, whatever the water is, I can take out. If it is natural,
water is above that level only, you withdraw. Whatever is below that level, you cannot withdraw. That means even by accident, sludge cannot come out.
I can withdraw if gravitation flow, if the tank, if it is space is available. If it is a
Exactly.
parallel tanks, then I have to take out by a motor pumper.
See, the design should be, it is never meant for taking out with a pump, because when you are pulling something
Oh,
using a pump,
oh,
you are also attracting a lot of sludge.
right. That is a gravitational flow only.
It should be gravity flow only.
Then it will be a very clear water, whatever is there, that level it will be extracted.
Exactly.
Here, after extracting this one, if it is MLS is high, MLSS normally we are making 3,500.
Yeah, you can go up to 4,500 in your SBR tank.
If it is more than that one, then I have to take out the sludge.
To take out the sludge, exactly.
To take out the sludge, I have to use submergible pumps, or is there any other provision also can be accommodated?
You can use submersible pumps, you can use airlift pumps, you can also use centrifugal pumps, but you have to ensure that the centrifugal pump can handle suspended particles.
Airlift pump also can be used.
It can be used. Airlift pump also can be used.
If it is a little 1-2 meters high only, it can be. I think it will not be suitable for higher altitudes.
No, there is nothing like that. If you look at examples for airlift pump, your borewell hand pump, what we see in villages, is an airlift pump. You are pumping a small quantity. When you are pumping the handle, you are injecting a small quantity of air to the bottom of the water column.
Okay.
So the water is raising up and you are taking it. So even 4 meters, 5 meters, airlift pumps work commonly. That's not an issue at all. They have to be
Okay.
properly designed. That's all.
Oh. So the airlift pump suppliers, I need some information. Please note.
Yeah, please connect with our team. They'll help you on that. Kishore,
Okay.
please make a note of this.
Sir, we are also into this one only. We'll guide you, sir. Once we have a
Okay.
inspection, we'll guide you in detail. Yeah.
Okay. Thank you.
Thank you.
Okay. Any more questions, please?
Sludge.
Sir,
Yeah, please go ahead.
sir, treated water quality of the TSS and turbidity is good in SBR or MBR, sir?
You are saying MBR, not MBBR, right?
Yes, sir. Yes, sir. No. MBBR
MBBR.
versus SBR.
See, please understand this. If you are looking at water before sand filter, carbon filter, the sand filter, carbon filter are basically meant for removing your suspended solids after treatment. The outlet of clarifier in SBR, in MBBR will give you better quality water because you have a properly designed settling tank there,
Yes,
right?
sir. Yes.
Whereas in SBR, there are always challenges. How you are withdrawing water, from which area you are taking out water, what is your launder size, or what is your decanter size. These are all the challenges. So suspended
Yes, sir.
particles point of view, your treated water quality will be better in MBBR. But BOD COD
MBBR.
point of view, it will be lower in SBR. Water
SBR.
quality is always better in SBR.
SBR.
But it is only a marginal difference. Rather, I would say how we should select or suggest MBBR, SBR is based on the client requirement. If the client is somebody where there is no standard load, that means there is no constant load, something like a hotel, hospital, educational institution, there SBR is advisable. If it is a constant load, that means like something like an apartment complex or residential project where you are getting more or less plus or minus 5% same quantity of sewage every day, you should go for MBBR with your eyes closed. There should be no second thought.
Okay, sir.
हेलो हाँ सर
Sir,
फुलर जी
also,
हाँ
hello,
फुलारे
sir.
जी प्लीज गो अहेड सर.
हाँ सर तो
Yes, sir.
अपन जो सर फीड फ्लो जो फीडिंग करते हैं एसबीआर टैंक में ओके
जी हाँ
वो फीड फ्लो क्या रहेगा और कितना टाइम फीडिंग करते हैं अपन उसको
सर ऐसा देखिए 24 घंटे का टाइम है आपके पास 3 बैच
बन
निकालना है.
हाँ
ओके सर, मतलब हर बैच का 8 घंटा हो गया, 8 hours. Batch duration is 8 hours. In these 8 hours, 1 hour is meant for filling.
1 hour is filling. Okay.
Filling. That means your feed pump capacity should be
Right.
equivalent to your batch volume. If you're talking about a 100 KL STP, your 3 batches, that means batch volume is 33 or 34 KL. Your feed pump capacity should be 34 KL per hour. Okay. And after 1 hour filling, aeration is 4 hours to 5 hours. Okay. Let us take 5 hours aeration.
Aeration 5 hours. Okay.
5 hours.
Okay.
Then 1 hour settling.
1 hour settling. Okay.
Another 1 hour withdrawing of water, decanting.
Decanting. हाँ.
Okay,
सर
sir.
ये डिकैंटर
So,
क्या कैसा वर्क करता है? डिकैंटर बोले तो एक नॉर्मली वाल ओपन होता है और डिकैंटिंग प्रोसेस होता है. इसमें अलग से कुछ टेक्नोलॉजी या कुछ ये है इसमें?
सर उसमें काफी बड़ा इट इज बेसिकली ए डीप साइंस. SBR में एडवांटेज यही है कि आपको जो पानी ऊपर फ्लो हो रहा क्रिस्टल क्लियर वाटर टॉप लेयर्स में है उसको ही आप विथड्रॉ करना चाहिए. अगर आप
बराबर
सिर्फ
है.
वॉल खोलते हैं तो वॉल के साथ में आपको स्लज भी काफी ज्यादा स्लज भी आ जाएगा. So you
हाँ.
require a floating decanter. I'll share some videos. Maybe we have some municipal STP videos in our YouTube channel. I'll ask our team to share links to you. Right?
ओके. सर ये दूसरी बात, ये
You-
अपन जो एरेशन टैंक है इसमें अपन एमएलएसएस कितना मेंटेन क्या रहता है मेंटेनेंस? जैसे अपना एक्सटेंड एरेशन में 3 to 4,000 एमएलएसएस अपन मेंटेन करते हैं. ओके.
जी.
तो अपन अपना आरबीसी में कितना, एसबीआर में कितना अपन ये करते हैं? हाँ.
We can go up to 5,000, 6,000 also, but it's very difficult to maintain at such levels. Very
Okay.
difficult because on and off you're switching off the blower. When your blower is off, even if you target 6,000, वो कम हो जाएगा. A lot of bacteria will die. Especially if there is a lot of gap between batches, bacteria does not survive. When the plant is running at full capacity, you can maintain 6,500 also. बैच में बीच में ज्यादा ड्यूरेशन है तो एमएलएसएस मेंटेन करना मुश्किल हो जाएगा.
बराबर है. राइट. ओके सर. ओके, थैंक यू सर.
Okay, sir. Thank you. Mr. Sundar, you were asking some question.
Sir, I forget, sir.
Okay. Mr.
Sir,
Arshad,
that
how are you?
MLS maintenance, sir. The MLS maintenance, because MBBR,
Okay.
we maintain the sludge settling volume. If the
Right.
sludge settling volume increases, we can transfer the sludge to the sludge bed. That's why we are
Exactly.
maintaining the sludge volume in the MBBR. But in the SBR, we cannot do anything, sir. We cannot check the settling volume also.
No, sir. It's not like that. You have to take a sample and settle it, check it into a jar,
Like same
into an
with
MLSS
MBBR.
jar. Same. There is no difference between checking for MLSS whether it is MBBR or SBR.
Okay, sir.
Conceptually, it is same. There is no difference.
Sir, we can maintain much MLSS in SBR, sir, compared to MBBR.
It is little difficult to manage, especially when the plant is new, like we discussed. Let us say there is a lot of gap. The aeration process should happen every 3 hours or 4 hours, right?
Yes, sir.
Let us say your blower is on for 5 hours. That means in 15 hours, in 24 hours, 15 hours, your blower is on. The remaining is only 9 hours. The gap between batch is 3 hours. So if your next batch is not starting after 3 hours, some bacteria tend to die. So
Yes,
when
sir.
there is a gap between two batches, your MLSS will come down. Bacteria will not survive. This is a
Yes, sir.
major challenge.
Yes.
सर
In this
अपन
case,
इस
we
केस
will
में
maintain much MLSS.
Sorry, please come again.
In this case, we can maintain much MLSS.
We should target at least 5,000 anytime.
Okay, sir.
That should be the target. Even if it goes down a little bit, 4,000 also, not a challenge, but we should target.
Yes, sir.
Measuring this MLSS only by it is a transparent flask only.
Yes. MLSS measurement jars will be there. So you have to use
Measurement
that.
jar.
Yeah.
And filling and leaving it for some time, it will settle down. Then we can see that level. You mean
30 minutes. You have to give it 30 minutes time. After 30 minutes, how much is there in the jar. A jar will be having measurement gradations on that, so you will know how much exactly is the volume of your MLSs as a percentage.
Okay. Thank you, sir.
हाँ सर, मैं फ्लोर बात करूँ। तो
हाँ सर, प्लीज।
हाँ, अपन जो 3 बैच किया है, अपने 8 आवर्स का एक बैच किया है, ओके। तो ये बैच अपन नंबर ऑफ बैच बढ़ा सकते हैं क्या इसका?
सॉरी, आई डिडंट अंडरस्टैंड दिस क्वेश्चन, कम अगेन प्लीज।
हाँ, एसबीआर का जो बैच है, ओके,
हाँ,
वो बैच कैसा डिसाइड करना और मिनिमम कितना रख सकते हैं और मैक्सिमम कितना बैच कर सकते हैं अपन ऐसा?
see, there are some places where I have seen 6 batches also being treated.
Okay.
Per day, 6 batches also were getting treated in a Himachal Pradesh municipal STP.
Okay.
That is the maximum I have seen. But 3 to 4 batches is the norm. कितना रख सकते हैं?
हाँ.
4 से ज्यादा रखेंगे तो आपको शायद जो efficiency चाहिए वो नहीं आएगा. Normally,
Okay.
what is done is in large capacity STPs, instead of going for one batch reactor, you have 2 parallel batch reactors. Okay, sir.
Okay. हाँ.
Let us say आपके पास 1500 KL का वेस्ट वाटर है per day to be treated. So 500 KL का एक बैच, एक रिएक्टर नहीं लेके आप क्या करते हैं, इसको 2 पार्ट्स में डिवाइड करते हैं. It's like having 2 STPs of 750 KL. So you will have a batch reactor capable of handling 750 KL each. So at any point of time, one is receiving wastewater, one is in process.
Right. Standby working.
हाँ, तो पैरेलली ऐसा करने में आपको सिविल कॉस्ट कम हो जाएगा एंड द सेम इक्विपमेंट इज यूज्ड, मैकेनिकल इक्विपमेंट इज सेम ब्लोअर इज यूज्ड इन बोथ. सिर्फ डिफरेंस इतना है कि उसमें 4 घंटा ही ब्लोअर चलेगा, इसमें 12 घंटा चलेगा, उसमें 12 घंटा चलेगा. मतलब आपका 24 घंटे ही है दिन में.
बराबर है.
So their aeration is restricted to 4 hours.
ओके. तो एरेशन मिनिमम कितना रहना चाहिए सर बैच में? 4 आवर्स?
4 आवर्स से कम होगा तो शायद बराबर ट्रीटमेंट नहीं होगा सर. आई फील 4 आवर्स इज द मिनिमम रिक्वायर्ड.
ओके. सर, और ये जो फिलिंग टाइम है, अपन फिलिंग टाइम कम भी कर सकते हैं ना, रॉ पंप का फ्लो बढ़ा के अपन हायर कैपेसिटी से लेके
कर सकते हैं. जी हाँ, बट 1 आवर,
वो टाइम अपन, हाँ,
1 hour to 1.5 hour. It should not be definitely more than 1 hour, 1.5 hour. 1.5 hour से बढ़ के नहीं होना चाहिए. कम हो सकता है, ज्यादा नहीं हो सकता है.
ओके. और सर, ये सेटलिंग टैंक का कैपेसिटी 1 आवर्स इज सफिशिएंट?
सेटलिंग टैंक मतलब इसमें सेटलिंग टैंक अलग से नहीं रहता है ना, सेम टैंक यू आर यूजिंग. सेटलिंग टाइम यू मीन टाइम यू आर टॉकिंग अबाउट टाइम, आई सपोज.
हाँ.
That's why this 4 hours is recommended.
1 hour से ज्यादा सेटलिंग टाइम नहीं है अपने पास. अगर वो टाइम में सेटल नहीं हो रहा है तो हमें एक्सटर्नल केमिकल्स यूज करना चाहिए. एलम, पॉलीइलेक्ट्रोलाइट, ऐसे केमिकल्स यूज करके कंपलसरी सेटल होना चाहिए.
सर, अपन ये जो केमिकल यूज करेंगे तो बायोलॉजिकल जो ये प्रोसेस, उसके ऊपर कुछ इफेक्ट्स होगा या जो
नहीं
अपना
सर, those chemicals are very small volume chemicals. For example, if you use any polyelectrolyte or ferric alum, उसका डोसेज 2 to 3 ppm रहेगा, उससे ज्यादा कुछ असर नहीं पड़ेगा. They don't impact your pH or working conditions.
ओके सर. राइट. ओके.
This the alum dosing when we are doing a 2 to 3 ppm for settling. This what is the quality of alum we need to use?
Sir, these are all commercial grades only. You have to just check what is available in the market and dilute it proportionately and use. And ferric alum is maybe 20 rupees to 25 rupees per kg you should get. So थोड़ा कम ज्यादा होने से भी प्रॉब्लम नहीं है. Only thing is, please understand this, it is not only important to dose, but it is also important to mix. मतलब आपका एरिएशन स्विच ऑफ होने का एक 1 hour पहले से आपका डोजिंग शुरू होना चाहिए, so that they get mixed thoroughly. If they are not mixed properly, settling will not happen. मतलब आप ब्लोअर ऑफ करने के बाद में केमिकल डोज करते हैं तो ज्यादा फायदा नहीं है. It's not beneficial to dose chemical after settling. Just before you switch off the blower, at least 30 minutes before you switch off the blower, you add the chemical and spread it across the tank volume.
In terms of liters per hour, how much it could be when it is 2 to 3 ppm?
See, 1 ppm means 1 gram per kl. If you are treating 100 grams, it is 100 kl, it is 100 grams. 1 ppm is equal to 1 gram per kl.
Okay. So accordingly, we have to set our meter.
Yeah. Based on the volume of your tank.
Yes.
Sir, next questions.
Please.
100 KLD capacity. Okay.
Okay.
So
Okay.
SBR tank capacity is the same, 100 KLD.
मैं समझा नहीं आपकी बात. 100 KLD STP है आपके पास.
STP का कैपेसिटी है और SBR का टैंक का कैपेसिटी क्या आएगा?
SBR बैच रिएक्टर का ऑलमोस्ट 100 KL आएगा. 100 KL का ही लगाना चाहिए आपको. उसमें 66 KL स्लज रहेगा, 33 KL, 34 KL आपका फ्रेश सीवेज रहेगा हर बैच में.
और 34%. राइट ना?
सॉरी, योर वॉइस इज ब्रेक. हाँ, 34 KL का बैच रहेगा. 34 KL पर बैच रहेगा. 66 KL आपका स्लज रहेगा.
सर, तो इसमें अपना सिविल कॉस्ट तो ज्यादा रहेगा ना MBBR के कंपैरेटिव?
MBBR से कंपेयर करेंगे तो सिविल कॉस्ट ज्यादा रहेगा. यस, इट इज मोर वॉल्यूम वाइज ज्यादा रहेगा, बिकॉज one is your SBR tank size is bigger, your chlorine contact tank size is bigger.
Right. Okay, sir. Thank you.
Okay. But it has its own place. जैसा म्युनिसिपैलिटी में है तो MBBR काम में नहीं आएगा म्युनिसिपैलिटी में. You have to essentially go for SBR, and large capacity STPs you have to go for SBR.
Okay. तो लार्ज कैपेसिटी के लिए ये बेस्ट रहेगा टेक्नोलॉजी.
SBR is always better for large capacity. Something like 500 and above. I personally recommend SBR.
Okay, sir. Okay.
Any more questions, guys?
I have one question, but it's not related to this one. It is related to MBBR media. Okay. Last time you suggested to go for 1 lakh units per meter cube.
1 lakh 10,000 units make one cubic meter.
One cubic meter. But who are the guaranteed suppliers for this, sir? I need some suggestions, sir.
Sir, no, people are selling this media by volume. They say 1 cubic meter, but they'll give you some 60,000 to 65,000 pieces. Nobody is giving you 1 lakh or 1 lakh 10,000 as required.
So in that case, how we can ensure that one it is 1 lakh, it is at least it is coming.
We have to buy more. It's like this, sir. That guy will charge you some 15,000 or 10,000, whatever is the rate. You have to, when he is saying something is 1 cubic meter, it actually is not 1 cubic meter. It is 0.7. With that knowledge, we should buy. If I need 10 cubic meters, probably I need to buy 15 cubic meters because it is equivalent in terms of numbers. So
in that case, how I can ensure this one? It is I am doing this one 0.7 meter cube or 1 meter cube. You mean what I mean is it is if it is a specific, if it is the right quantity, it is 1 lakh.
One is you need right quality of suppliers, vendors, right? And
that
when you are asking me to supply more, let us say my definition of 1 cubic meter is only 60,000 pieces. I am charging X price. There is a Y vendor who is giving you 1 lakh pieces, but he is charging Z price. His price will be more, obviously.
Yes.
But per unit price might be same. You ask per unit, how much you will charge me per piece. So per piece, what is the weight and how many tons you are giving? Look at it like that. That will be easy. Instead of going on cubic meter basis, go on per unit basis, per piece basis.
That means one piece making 1 gram?
Approximately 0.95 to 1 gram.
0.95.
No, may not be. That will be, I'm not sure about the weight. You need to check.
Okay, sir. Okay, sir.
Maybe you can take 100 pieces and then weigh and extrapolate the data.
Okay. Thank you, sir.
Sir, for a
Okay.
supplier, we are there, sir. We'll come and visit once. Last time also we missed. Now we have a team available. We'll suggest our team to
Okay.
visit. We also do all the
Okay.
supplies. We are also coming with online stores so that it is convenient to our customers to purchase. That also will share you immediately before August 15th. We are also doing that. We'll convey that also.
Okay. The genuine suppliers we need so that we are doing a right job. But when we are failing a spurious material if we are using, then our failure will be there.
Yes.
Yes. So to avoid that only, we are coming up with online, so that online stores. So from your
Yeah.
that
So
will be our,
at least knowledgeable people, if they are selling this one, they are understanding and quality checking, then
Yes,
it will be trustable and it is a advantage for us.
We want to bring transparency into the industry by putting it online, all the information.
Okay, sir. Thank you, sir.
Okay, sir. Thank you.
Good.
Thank you, guys. Have a wonderful day, all of you. Thank you so much for joining. Next week, our topic is going to be membrane bioreactor, MBR, everything about MBR. That is going to be our topic. I'll ask my team to share the joining links today itself. All
It
right.
is okay, sir. And another one session is required for pressure filter and activated carbon filters. And
We'll definitely take up, sir. Certainly. It will be a pleasure.
UV system also, it is a final stage area.
Certainly, sir.
So we'll be enlightened. Thank you, sir.
Thank you so much, sir. Thank you for your suggestion also. Thank you.
Thank you,
Have a
sir.
wonderful
Thank you.
weekend, all of you. Bye-bye. Thank you, Gautam. Bye-bye.
Gautam sir, you are not asking any questions today. Are you available?